Hey everybody, this is a guided walkthrough for TryHackMe Advent of Cyber day number 6 over at tryhackme.com as part of their Advent of Cyber event. So this room is called Malware Analysis Egg-ecutable. And today, what are we going to be doing? Let's take a look. All right, so after you join the room, we want to go down to our introduction, task number 1, and we're going to read off what's going on in the story. So the town of Wareville remains quiet in the middle of the night, while the residents of Wareville are nicely tucked up in bed, blissfully unaware. The SOC team at the Best Festival Company, TBFC, remain alert, poised, and ready for whatever may face them. Monitoring their screens, armed with a freshly poured mug of hot cocoa, the elves at the SOC watch their dashboards diligently. Suddenly, the elves received an email in unison from Elf McClaws, head of Elf Affairs, in their inboxes. It reads, from Elf McClaws, subject: a new schedule awaits. Attachments: hophelper.exe. To all elves, going forward, we will be using a new program for creating and viewing team rotas. This new program will revolutionize how rotas are made here at the Best Festival Company. Please contact IT support if you need help, if you have issues running the program. Kind regards, remain the best, Elf McClaws, head of Elf Affairs. Why is Elf McClaws working at 3 a.m.? Screams a member of the SOC team in the background. They're right, something is amiss. Elf McBlue is immediately suspicious. Their years of experience in the SOC have given them the wisdom not to download out of the blue executables. Without McSkitty's wisdom, Elf McBlue takes charge, loading up their malware investigation toolkit. The investigation begins. Okay, so what are our learning objectives for today's room? Today's room will have you taking the place of Elf McBlue, a highly talented member of the Best Festival Company's Malware Investigation Squad. You've been tasked with investigating a highly suspicious executable that is being shared within the company. In today's room, we will cover the following: the principles of malware analysis, an introduction to sandboxes, static versus dynamic analysis, and tools of the trade, PE Studio, Procmon, and Redshot. So what do we need to do today? So do we need to start a VM today? Yes. Is there split screen available? Yes. And are we given credentials to connect directly to the VM via RDP, VNC, or SSH? Yes. Okay, so what we want to do is we want to set up our virtual environment. Just go down to this green button over here under Set up your virtual environment and click it to start up the machine. So the machine is going to take a couple of minutes to start up, but in the meantime, what we can do is we can read up on what's going on today. Okay, so just click on the answer, I have access to my sandbox environment, check. Okay, and then we'll go over to task number 2. So we're talking about the principles of malware analysis. Let's talk a little bit about this. Malware analysis is the process of examining a malicious file to understand its functionality, operation, and methods for defense against it. By analyzing a malicious file or application, we can see exactly how it operates and therefore how to prevent it. For example, could the malicious file communicate with an attacker's server? We can block that server. Could the malicious file leave traces on the machine? We can use these to determine if the malware has ever infected another device. Instead of fearing malware, we can take a proactive approach by translating technical findings into practical defense measures and understanding how the malware fits into an attacker's techniques. There are 2 main branches of malware analysis. There's static and dynamic. Static analysis focuses on inspecting a file without executing it, whereas dynamic analysis involves execution. We will come to these shortly. So we're also talking about sandboxes. In cybersecurity, sandboxes are used to execute potentially dangerous code. Think of this as disposable digital playpens. So these sandboxes are safe, isolated environments where potentially malicious applications can perform their actions without risking sensitive data or impacting other systems. The use of sandboxes is part of the golden rule in malware analysis. Never run dangerous applications on devices that you care about. Most of the time, sandboxes present themselves as virtual machines. Virtual machines are a popular choice for sandboxing because you can control how the system operates and benefit from features such as snapshotting, which allows you to create and restore the machine to various stages of its status. To reiterate, it is imperative to understand that potentially malicious code and applications should only be run in a safe, isolated environment. From now on, this room will refer to malicious code and applications as samples. With these fundamentals covered, let's move on to the practical section of today's room. The following will demonstrate a sample. You must apply these techniques to the hophelper.exe file presented to you within the hophelper folder on the desktop of the practical VM. Okay, so the first thing we're going to be talking about is we're going to be talking about interactive static analysis. I mean, yeah, interactive. I guess static analysis doesn't really go with interactive. Anyways, as we alluded to previously in this room, we will use static analysis to gather information about a sample without executing it and digging deep. Static analysis can be a quick and effective way to understand how the sample may operate, as well as how it can be identified. Some of the information can be gathered from static analysis have been included in the table below. Okay, so we've got checksums. So checksums are information used within cybersecurity to track and catalog files and executables. Basically, checksums are kind of like digital fingerprints, so that we know that we're dealing with the same file, the same characteristics. Okay, so checksums, they're also strings. Strings are sequences of readable characters within an executable. This could be, for example, an IP address, URLs, commands, or even passwords. So an example of a string could be an IP address over here. Okay, so the next thing is imports. So imports are a list of libraries and functions the application depends on. For example, rather than building everything from scratch, applications will use operating system functions and libraries to interact with the OS. These are useful, especially in Windows, as they allow you to see how the application interacts with the system. So for example, we've got this import right here. This library is used to create a file on the Windows system. Create file W, okay? And we've got resources. Resources contain data such as the icon that is displayed to the user. This is useful to examine, especially since malware might use a Word document icon to trick the user. Additionally, malware itself has been known to hide in this section. So let us continue. Okay, so however, it's important to note that regardless of how a sample may appear or function, we don't truly know until it's executed. Attackers use techniques such as obfuscation to obscure how a sample appears, primarily to evade antiviruses, but also... Oh, why was it terminated? Okay, so I need to restart my machine. Just a second, everybody. Okay, so demonstrating PE Studio. This section of the room will demonstrate using PE Studio on an example called downloader.exe. Please note that the information you will see from this demonstration sample, the sample you will be analyzing will be different, but the techniques will still apply. So please note that it is imperative you do not launch the hophelper.exe executable yet. So first we will use PE Studio to gather information about the executable. Okay, so launch PE Studio, load the executable into PE Studio, click on the Indicators tab in the dropdown, and look for the SHA-256 sum. Okay, so we can do that over here on our virtual machine. So the stuff that we're dealing with in today's task is we're dealing with Windows stuff. Usually we deal with Linux environments, but today we're dealing with Windows. So what you want to do is you want to go to the bottom of the screen so that we can look at this desktop view in full screen. So go to the center here, and then go down. There's a button that's labeled View in Full Screen. You want to click on that. Okay, so let's go ahead and start up PE Studio. So PE Studio, there's a... Wow, why is the resolution so bad? Anyways, we'll start up PE Studio, click on the icon shortcut, and then we can open up our file. So the file we want to open up is, just click on File, then click on Open File, and then you want to click on Desktop, and then you want to click on the hop helper directory here. So inside of the hop helper directory, there is this executable right here called hophelper.exe. Select that and then click open. Okay, and what we want to get from here is we want to get the SHA-256 sum from the program. So what we can do is right here immediately after we open up the program, there's going to be this value right here. So we can click on it and then we can right click, and then select copy line. So we're going to copy that line and then we're going to go to our terminal. We're going to paste in the line and then we're going to need to copy just the SHA-256 string. So the reason why we do have to do it like this is because the copying is a little bit finicky. It's probably the best that you do it this way. So we're going to need to use this SHA-256 string right here to answer one of the questions. So let's go ahead and answer that question. Okay, let's go back. We'll go back to the TryHackMe room and we will exit the split view. And then we will go down to the questions here. Static analysis, what is the SHA-256 sum of hophelper.exe? We'll just paste in our answer here and we'll click on check. Okay, and then we'll go back up to where we were. Okay, so what's next? So next we will proceed with reviewing the strings of the executable. You can do this by clicking on the strings indicator on the left pane of PE Studio. Okay, so PE Studio, over here, we can click on strings. We'll go down and then there's this one section here, click on that. So let's go on. And what do they want us to do? So in the context of malware analysis, strings are the sequences of readable characters present within an executable. This could be, for example, IP addresses, URLs, commands, or even passwords. As a malware analyst, it's great to have a look at these, as they could reveal the attacker's command infrastructure, which we could use for our defenses. So now proceed to review the strings on the sample hophelper.exe provided to you on the analyst machine to answer question number 2. Okay, so we can go ahead and go to our strings over here. We could look through this stuff all day, but what we want to do is we want to look up a flag. So if we know that all of the flags in TryHackMe start with, so if we know that all the flags in TryHackMe start with the letters THM, we should probably go into the machine and then sort by value. And sorting by value is going to get us the alphabetical order of these strings. So we'll go over to the letter T to look for the flag. So T. So TH. THM. Okay, so this is the flag over here. So it's called THM strings found. So we can click on it, then we can right click, and then copy the line. So we'll copy the line, then we'll go over to here, and we'll just copy the flag, and then we will go over to the TryHackMe room. We need to go down to the bottom and answer the question. So the question for number 2 is static analysis within the strings of hophelper.exe. A flag with the format THM something something exists. What is the flag value? Okay, and then we will finish that one, and then we'll move on to the next section. All right, so the next section, we're dealing with a different program. Okay, so we're doing interactive dynamic analysis. So this section of the room provides a brief introduction to dynamic analysis. As you recall, dynamic analysis involves executing the malicious sample to identify its behaviors and how it interacts with the operating system. So we're going to be using this program right here called RedShot. RedShot is a widely used utility, especially when analyzing malware on Windows. It works by creating 2 snapshots of the registry, one before the malware is run and another afterwards. The results are then compared to identify any changes. Malware aims to establish persistence, meaning it seeks to run as soon as a device is switched on. A common technique for malware is to add a run key registry, which is frequently used to specify which applications are automatically executed when the device is powered on. Okay, so it says here, before executing the malicious sample, hophelper.exe, let's create a snapshot of our registry as it currently is so that we can compare the difference once the sample has been executed. Okay, so let's load up Redshot and create a capture of the registry as it currently exists. The shortcut to this has been placed on the desktop of the analyst machine. First, change the output directory of the capture to the user's desktop using the box with the 3 dots in the output path section. Then once set, we can create our snapshot. Press first shot and then shot on the dropdown. Please note that this may take a few minutes to complete. Okay, so this is what we're going to do. Okay, so here we're done with PE Studio, so we can close it. And then we'll start up the Redshot program over here. Okay, so yes. And we need to change the output path to the desktop. That's what they wanted us to do. So desktop, okay. And then click on first shot. So this is going to take a snapshot of the registry as it is right now. Okay, shot. So this is going to take a little bit of time to complete. And then we can do the second shot after we run the malware binary. We can get the other thing ready by opening up Hop Helper. So the Hop Helper folder over here, I hope Redshot didn't just crash. So the thing about these Windows machines is that the Windows machines are not they're not provisioned with a lot of resources. And that means that they're going to be a little bit slow. But yeah, so it looks like the first snapshot is completed. So the thing we need to do next is we need to run the Hop Helper malware program. So we run Hop Helper. And when Hop Helper runs, you're going to notice some weird things happen. So we see here that Hop Helper is running, and then it changes all of the desktop icons to these little Easter egg things. Okay, so after we run the Hop Helper program, it says here, King Malhair sends his regards. So we've obviously got some malware running on our system. Okay, so what we're going to do next is go back to Redshot, and we're going to create the second snapshot of the registry to see how the malware has changed it. Okay, and we'll just wait for this to complete. And I think it should be done. Just need to wait for the program to come back to us. But in the meantime, we can talk about what the rest of this task wants us to do. Okay, now that we've taken a snapshot of the registry, we should proceed with executing Hop Helper. Okay, we just did that. And once we have executed our sample, let's return to Redshot and compare our second snapshot using the same procedure as before. Okay, we've already done this. Now, after a few seconds, let's press the compare button that appears. Okay, let's go ahead and do that. So click on compare. This is going to take a few seconds to finish. Okay, we can search for the executable within the log that opens up. So before we move on, I'm just going to make sure that we're getting the information for the next question we need to run. We need to answer rather. Okay, so which registry value has the hophelper.exe modified for persistence? Provide the full path of the key that has been modified. So provide the full path for the key that's been modified. Okay, registry value, which one has been modified? Let's go over to the machine. And we see over here, and we see here keys added, HKU, and this really long string over here. So I wonder if this is the answer for our question, but there's a bunch of other stuff that's been modified as well. If we take a look at here, we see that there are keys added between the two snapshots and values deleted over here, and values added over here as well. Okay, so I think what we're looking for is we're looking for the run, the run value over here. So it runs hophelper.exe. So let's just copy this one here, and then we'll provide this as the answer. Okay, paste that in, check. That was the correct answer. Okay, let's go back. So we're going to be using another program now, and we're going to be using a program called procmon. So next we will explore using procmon, or process monitor, from the sysinternal suite to investigate today's sample. Process monitor is used to monitor and investigate how processes are interacting with the Windows operating system. It is a powerful tool that allows us to see exactly what a process is doing. For example, reading and writing register keys, searching for files, or creating network connections. So open Process Monitor, procmon. The shortcut has been placed in the desktop of the analyst machine. Process Monitor will automatically start capturing events of various processes on the system. Okay, so now execute the sample hop helper again and return to the Process Monitor to see how it interacts with the operating system. Okay, so procmon over here, let's go ahead and run that. So we don't need this anymore. We can close it. We can also close Redshot. And then we can run procmon. So procmon is this over here. Okay. And now we're running procmon. What they want us to do is they want us to run the hop helper program again. So let's go ahead and do that. So run hop helper. Okay, and we get this message again. King Malware sends his regards. Click OK, and after we do that, we can stop procmon. So we can click on this over here. Capture paused. Okay, so after the capture is paused, let's go ahead and go back. Okay, so let's see. Execute the sample hop helper again and return to the process monitor to see how it interacts with the operating program. We will see a lot of information here. Do not worry. We will come on to how to filter this shortly. So after allowing a minute to pass, ensure that the sample is fully executed. We will now stop capturing. To stop capturing more events, click on the play button in the toolbar of the process monitor. Okay, we did that. As you can see, there's a lot of information to scroll through here, with most recent events near the bottom. So you can see how various system processes are interacting with Windows. Nearly all of it we don't care about. So if we go over here, far from it for me to explain what exactly is going on. There's a lot of different operations that are being done between the different processes that are running on the system. So we've got a lot of PowerShell stuff going on. We've got a lot of Explorer.exe and all the other programs that are usually running on Windows systems. They're doing a bunch of different operations, and the thing is that if we try to take in all this information all at once without properly filtering out that information, it's going to be very, very difficult. So this is what we're going to do. Okay, let's apply some filters. After all, for this demonstration, we only care about the sample. So to do so, click on the filter button and then filter within the dropdown. So we're going to create a filter to filter out all of the events. So a new window will open, and then we can put in our matching filter conditions over here. So here we can create some filters to remove some of the noise that we don't care about. Because we only want to look at our program over here for the demonstration, we can apply a filter like so. Apply the process name filter, set the condition to is, put in the name of the process we want to see within the text area, press the add button to apply this filter, and then click OK to save. So we can do this in our machine here by clicking on filter, and then click on the filter button. And then what we're going to do is we're going to set process name is hophelper.exe. We click on add, and then we click on apply. Okay, so after that, we can see in here that only process name hophelper.exe appears in the list, and we see all of the different stuff that's being done in here. Okay, let's move on. So once done, return to the main process monitor window, and we can see that the filter has worked. So we only get the stuff from the process that we want. Now it is much easier to investigate how the process is interacting with the operating system. Here are some operations that may be of interest to us. We've got reg open key, create file, TCP connect, and TCP receive. However, as you can see, there's still a lot of information. We can further apply filters to look for specific things that we want to investigate, such as these aforementioned operations. So to do so, we're going to return to the filter header and then create the filter that we want to apply. For example, we can filter by operations, and let's do so below, filtering for any TCP operation. Okay, so TCP operations, we can filter for those by doing this. We go over to filter, click on filter, then we do operation. So click on operation. Operation begins with TCP. So just type it in, TCP, and then click on add. So operation begins with TCP, and then we apply that filter. And then we press OK. So we see that there are only four operations here. So TCP connect, TCP send, TCP receive, and TCP disconnect. So we've got we have a much more narrow list of events to look at now. Okay, well done. This concludes the demonstration for today's room. Remember, you will need to apply to what you've learned here on the hophelper.exe executable. That has been placed in the hophelper folder. Okay, so I think we've got one more question to answer here. So filter the output of the procmon for TCP operations. What network protocol is hophelper.exe using to communicate? Okay, make sure that you have executed this. Okay, so we're looking for a network protocol. We'll go over here and we can click on any one of these. Hold on. Okay, so we see that all of these operations here, they use the path that includes HTTP. So HTTP is a networking protocol, so this is probably the answer they're looking for. So we can go over here and we can just type in HTTP. Okay, so bonus, can you find the web panel that hophelper.exe is communicating with? Well, I was actually not able to complete this portion of the. I was not able to complete this answer, but if any of you know how to answer this question, let us know in the comments, or let us know in let us know in the comments, and I would be happy to learn from you. All right, so the last thing we need to do is we need to click on the check, and we need to click on this last check, and then we're finished the room. Okay, everybody, this was a guided walkthrough for day number 6 from the Advent of Cyber event for 2025 over at TryHackMe.com. The room was called Malware Analysis Executable, and if you enjoyed this guided walkthrough, please click on the like and subscribe buttons on the video and leave a comment underneath the video. But until next time, HackerFrogs, out.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.